What's up guys, welcome to your 13th Pygame tutorial, and in this tutorial I'm going to be going over how to fix that problem we had last time with our animation, and we're going to be able to control the speed based on time. And if you're wondering, alright, why would we want to do this instead of just doing it like we did before? Well, before we had an animation based on how fast this loop could execute. So if you had to move 1 pixel every time the loop execute, it would be faster on computers with a faster processor and slower on computers with a slower processor. And when you're building a game, you don't really want it faster on some computers and slower on others, especially if you're going to have like high scores and stuff like that. So to do this, we need 3 variables. We need the x coordinate. Let's just set it to 0 to begin with, same as last tutorial. The next thing that we need is a clock object. Now in Pygame there's a built-in function called a clock, and this is pretty much a clock on your computer, and this is so you can work with time. So Pygame in the time library or module, and then go ahead and click clock. And after this, what you want to do is set a speed for your animation, and I'm going to set it equal to 250 pixels every second. And once I use these once I use these variables, you'll understand what it does pretty much. So after you got your 3 variables, let me move that down so you can see them. And after you blit your ball, here's what you need to do. The first thing that we need to do is calculate millisecond. So milli equals clock tick. Now, why is this important, you ask? Well, I'll answer that for you. Whenever you use clock tick, it calculates 1 tick equals 1 millisecond. So unlike how fast your loop executes, a millisecond is the same on a fast computer, is a slow computer, whatever. This isn't based on how fast your computer is, this is based on actual time. So now we get a constant across all computers. A millisecond is the same amount of time no matter who you talk to. So once we have a millisecond figured out, we usually want to convert it to seconds. So go ahead and write seconds and set it equal to milli divided by 1,000. And after you write 1,000, go ahead and write .0, or you can just write dot. And if you worked with Python and you follow my tutorials, then you know that whenever you divide by like 1,000, this is going to give you a whole number, and you don't want this. You want the detailed fractions of a number. So whenever you divide by a floating point integer, you get a detailed decimal point answer. And this is going to give you 0.001 seconds. So right now we have the variable 0.001 stored in seconds. And again, this gives you a constant instead of just how fast this loop can execute. So once we have 0.001 seconds, we want to calculate the distance moved. So let's go ahead and click dm and set it equal to seconds, seconds, and we want to multiply it by speed. And again, we made the speed in this tutorial. So when we multiply 0.001 seconds by 0.25, we get the distance moved. So now we can x plus equal dm, which is distance moved. And what this is going to do is move it a quarter pixel, or 0.25 pixels every millisecond, or 250 pixels every single second. So let me make sure I got everything right. Looks like it's all good. I can go ahead and run this. Run module, save it, okay. And now you see we can control the speed of our ball by changing that one speed variable. So now, instead of having this ball speed based on how fast your computer can process it, it's the same on every single computer no matter what. So that is how you can work with speed, and when you include that in your variable, speed pretty much evens out all computers and sets them all at an even level. And again, this is what you want to go for in the effect you want to achieve most of the time. So again, one last time, we started the x coordinate as 0 just because it's a good place to start. After that, we went ahead and opened our clock method, because what this clock object does is it allows you to give a constant across all computers. Next, we set a speed, which was 250, which we were going to use later. We went ahead and found a millisecond, and then we converted it to seconds, and went, alright, the distance moved is that seconds times your speed, and this gave you a constant for all computers. Again, can't stress that enough, but hey, I'm trying. And then you went ahead and moved that just like we did in the last tutorial. So that is your basics of how you can incorporate time to make speed constant across all computers. So I hope you enjoyed this tutorial. I hope you understand it at least a little bit. So thank you guys for watching. Don't forget to subscribe, and I'll see you next tutorial.